Two key reports underline the business potential of connected car data. McKinsey estimates that car-generated data could reach a market value of 450 to 750 billion US dollar by 2030. Meanwhile, Accenture and BVDV predict that while car-related revenues may decline, data-driven services will more than make up for it after 2015. On this slide, we look at both technical and business approaches to accessing connected car data. Technical approaches include the following. OBD2 dongles or devices which plug into the OBD2 port in the vehicle. These devices capture vehicle diagnostics data such as engine performance, fuel efficiency, and error codes. Black boxes with integrated sensors like IMU and GPS, which are installed in the vehicle to monitor driving behavior, vehicle movements, and location data. Smartphone sensors through dedicated apps that utilize the IMU and GPS in the phone, collecting data on driving patterns, location, and speed. The extended vehicle interface, a system operated by the OEM that allows third parties to access real-time data from the vehicle, such as maintenance alerts, fuel levels, and vehicle health metrics. For business approaches, data access can be secured by the following. Negotiating with OEMs for direct access to data, engaging with data marketplaces to acquire shared vehicle data, partnering with companies that introduce their own hardware and connectivity solutions into the car, such as smartphones, black boxes, or dongles. This slide illustrates the flow of connected car data to services. It starts with the car generating data, which is then sent to the OEM, the original equipment manufacturer. From there, the data may be shared with third-party service providers who process and utilize it. Finally, the data reaches the service user, enabling a range of connected services, such as maintenance alerts, navigation, and more. This simple chain highlights the key steps in transforming raw car data into valuable services for the end user. Importantly, data can also flow in the opposite direction. Services can send data back to the car, such as software updates, configuration changes, or even adjusting vehicle settings remotely. This slide outlines the flow of data through the extended vehicle interface, based on the concept as outlined by ACEA, the European Automobile Manufacturers Association. Data generated by vehicles is securely stored and managed by the manufacturer through their backend systems. This data is accessed via the extended vehicle interface, a platform selected by the OEM to ensure seamless, secure, and an efficient communication between the vehicle and backend systems. This interface allows for smooth data exchange, enabling various connected car functions and services. The vehicle generates data, which is securely sent to the OEM backend, to the OEM server, for storage and management. A third-party service provider can access this data either through neutral servers or directly from the OEM backend, depending on the business relationship. In the opposite direction, the vehicle can receive commands or messages sent to the OEM backend by third-party services and routed to the vehicle. These messages can trigger specific functions on the vehicle, such as executing remote actions or updating settings, enabling a fully interactive and dynamic connected car experience. A similar representation of the extended vehicle interface concept is provided by CLEPA, the European Association of Automotive Suppliers. VDA's ADEXO concept builds upon the extended vehicle interface and provides an overview of how vehicle data from different OEMs is managed and shared with backend systems. This data can be accessed by data consumers through two main routes, either directly via a B2B contract with the OEM backend or through a B2B contract with data intermediaries who access and facilitate the flow of data to third parties. This structure enhances the secure and efficient sharing of vehicle data across the ecosystem. The figure summarizes how data sharing via data marketplaces enables services like fleet management or pay how you drive insurance, which are provided by third-party service providers to end users. Data marketplaces manage unified access to OEM vehicle data, offering services such as multi-brand data access, standardized entry points, uniform data formats, as well as billing, payment, and consent management. With respect to legislation, connected car data sharing addresses over 20 different EU regulations on vehicle data access. These regulations ensure secure, transparent, and standardized access to vehicle data, while also protecting consumer privacy and fostering a competitive marketplace for data-driven services.